For this one, a 6-foot tall post casts a 10-foot shadow. A nearby tree casts a 60-foot shadow. How tall is the tree? And so this is one of those classic things that we use to measure things that would be really hard to measure otherwise, okay? And so like measuring the height of a tree, that's pretty tough, all right? Unless you're a really good climber and you have a really long tape measure, it's going to be a little bit of a pain, all right? So the idea here is this. So here's a post. I'm going to use my artistic abilities here. So there's a post in the ground. I should have drawn that a little bit smaller. Let me go down here. So here's the ground. Wow, terrible. Terribly done. I can do better. Ready? Here's the ground. Try to keep it a little bit flatter. Okay? And then I have this post in the ground right here. And then I have a tree. Okay, so my tree, nice big tall tree. I don't have brown as a color here, so I'll just use green still. All right? And so what happens here is that post casts a 10-foot shadow. In other words, there's a shadow on the ground next to this post that's longer than the post itself. And you've probably seen that before. It kind of just depends on where the sun is for the day. Okay? Likewise, the tree has a really long shadow here. And here's the thing, if the post has a shadow that's longer than the post itself, the tree's going to have a shadow that's longer than the tree itself. But the thing that's established here as we kind of look at this in terms of a shape that we know, this is 6 feet tall and this is 10 feet long. The shape that is created here is a right triangle, okay? And so the idea here is that this is a right triangle, and because of the nature of shadows in the sun, all right, all shadows are going to be proportional at any given time of the day if you're in the same area, okay? And so the idea here is that this right triangle right here this right triangle should be similar to the one that I already have drawn, should be proportional. And so right here I have the shadow of 60 feet. And so if we think about this in terms of a proportion, well, we just look at this. Here's the height of the tree right over here, okay? So I'll highlight it in purple. That's the height of the tree. So compare these pieces. When you look, the scale factor, the ratio between these two sides is given right here. It's 10 to 60. And so the ratio here is 10 over 60, which is 1/6. Well, when I compare the other sides, the 6 feet and the h, it should give me the same thing. It should also give me the 1/6. And so the idea here is when I compare this, 6 over h, it should also equal the same ratio, which is 1/6. And now I cross multiply, and I get h equals 36, so 36 feet. That's the height of my tree. Okay? And the thing that's really important about this, about measuring it this way, is all of those measurements were taken from the ground. When you think about using a tape measure to measure this thing, you can easily measure the height of this pole at 6 feet. And you can easily measure the length of this shadow at 10 feet. Likewise with the tree, you can easily measure the shadow of the tree at 60 feet. And now we can use that easily taken measurement to find the height of the tree. And again, measuring the actual height of a tree with a tape measure would be a real pain here. So we use things like similar figures to find the height of something like a tree. Okay?